Hi everyone. So in this problem we have an electric dipole and they are asking about the electric field at a point very far away from the dipole at a distance r greater than 2a, and you can see what is r here and you can see what is 2a. So the electric field at point P is the result of the electric field of the positive charge minus the electric field of the negative charge. So E is equal to E of the positive minus E of the negative. E of the positive is simply K Q over the distance between the plus charge and point P. If you look carefully, it's going to be R minus this distance, which is half of 2A. So it will be R minus A. So it will be KQ over R minus A squared minus E minus will be KQ over the distance from here till point P, which is R plus that small distance, R plus A, over R plus A squared. The question here, by the way, to see is E proportional to what? So we already know that in general E is proportional, or E is equal to KQ over R squared, which means E is proportional to 1 over R squared. But is that true for the electric field at a point far away from a dipole? That's what we are going to check. So let's continue with the problem. Keep in mind that R is much greater than 2A. When I say R is much greater than 2A, then this means if you square R and you square A, then the R squared is much bigger than A squared. So when you subtract R squared minus A squared, you can cancel the A squared and you will get R squared. As if you are subtracting, for example, 1 million out of 1 million. So it remains around 1 million, nothing happens. So let's see what we will get for E. So E will become KQ, and let's open the brackets, take a common factor KQ, you will get R minus A squared minus 1 over R plus A squared. So the technique here is to get something similar to R squared and A squared, so that when we subtract them, you will get only R squared. Now, here I'm going to use this trick. Here I can square the 1 and square the 1. Nothing will happen to the equation. So this one becomes, it looks like A squared on one side. Here I have A squared, and here you'll have B squared. And between them is the minus. So it's A squared minus B squared. And you know, this mathematical identity gives you A squared minus B squared will give you A minus B. So you will have A minus B into A plus B. Okay? So again, A squared, let's change the letter. Let's say, for example, x squared plus y squared, x squared minus y squared will give you x minus y into x plus y. So that's what I did here. This is capital X, it is x squared, and this is capital Y, x squared minus y squared. All right. Now, let's simplify and see what we will get. So E is equal to KQ. Now, R minus A and R plus A, I can take also another common denominator here, which is R minus A into R plus A, and which means I'm multiplying here by R plus A. Here I'm multiplying by R plus A, and here by R minus A, up and down. Okay, that's what I'm doing. So you will get let's continue. Erase those. Okay, so we'll get then r plus a minus r plus a, because we have the minus sign here. I have this minus sign here. And on the other side, we'll have also again r minus a into r plus a. And in the numerator, you will again get r plus a minus r, or plus r minus a, because I have the plus here. Okay, so we still have like 2 more steps. E is equal to kq. You will cancel now r minus r, and hence you will get 2a. And r minus a into r plus a, this one also is like x minus y into x plus y. So you will get r squared minus a squared. Same thing here. A minus a will cancel. And you will get 2r over also r squared minus a squared. Okay, then E becomes 4kqa multiplied by r. You multiply the numerators together. In the denominator, you will have r squared minus a squared power 2. Now, as I said, since r is much bigger than 2a, so r squared is much bigger than 2a squared, which means if you subtract a squared from r squared, you can estimate it to become r squared, as if I'm subtracting 1 trillion out of $1 out of $1 trillion. So nothing happens to the $1 trillion. It remains around 1 trillion. So this means E, by estimation, E becomes 4kqar. In the denominator, r squared minus a squared becomes r squared, and you already have this power 2. So r squared squared. So this one becomes 4kqar over r power 4. Then E becomes 4kqa. R divided by r power 4 will give you r power divided by r power 3. So then E now is not proportional to 1 over r squared, but it becomes proportional to 1 over r cubed. So you can take it now as a rule that for an electric dipole, at a point far away from the dipole, the electric field is proportional to 1 over r cubed and not 1 over r squared. So that's the answer here. Thank you for watching.